Yeah, so guys, so we have the HP laptop here, and is it HP-15 or 14? Okay, got this nice one. Okay, so let's check. This machine is working fine, but it has some complicated thing with it. We need to find it and fix it. Okay, so let's start. This machine power on. It's turns on. It's everything is working. Yeah, it's on. So you can see if it can get to the desktop and off again, and it's charging. Let's try again. Off. Okay, let's remove the charger and try. As you can see, without charger and it stays on. So this is the problem, and I'm praying that we can find the actual problem and fix it, because this kind of problem is very tricky. And I'm just looking at the one or two things. One is MOSFET. Yeah, because I will say maybe the battery is involved, but they told me they have changed the battery, so the battery has been changed. So we have to remove the battery away from this problem. So I'm just looking at the what they call it, MOSFET, first and second MOSFET. Maybe there's a short MOSFET in the first area, yeah. And there's other place I should check is what they call it, the MOSFET on the battery side. Also, maybe we have a high side being shorted. Yeah, that's the area I can, or maybe the BTO is doing that. But we need to take a look. See, without charger, everything is fine. And if you want to charge this machine, unless you turn it off and you charge it, because you can't do that whilst the machine is working. It will go off. It will go off. So I can even try the last time. The machine is off. So which you won't wait much more time. You have to start it right now. This is the first MOSFET. The bigger one is the first MOSFET. We need to check. It's good with the gate. Good with the gate. Good. Drain and gate. Everything is good. Drain gate is good. Source and drain is good. Okay, so let me check in this one. Good, 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 good. Okay, so this one is a charging IC, right? This one. Let me hear first and this is second. So first and second MOSFET from here, current sensor, and this is the main power. Here's the main power. That's why we have a big truck going here. You see? And it's a supplier to the other power stations. I'm talking about one volt, 1.2 for memory, 3.3, 5 volt, chipset, CPU, everything. This is the main voltage for all the power stations. So if this is the two MOSFET and this is the main, then this one is it protection or what? What is this? This one is current charging. Yeah, okay. You have a current sensor here, so this one is for charging. Yeah. It's passing here, creating a voltage for charging, and passing through here, and it's right. No, here is a charging. Here is a plus. So here, okay, it's charging this way. Okay, I know what it is. So first and second MOSFET, it's going here, and this thing is not coming here. This is the battery side. It's not coming here because yeah, it's not passing through the inductor, so it's not coming here. So random the battery voltage here is going here and passing here to the main. Here is the main, because first and second, here is the main and passing through the current sensor. So the current voltage from the battery is passing here, but the voltage which is going into the battery is coming from here, passing through inductor, current sensor into here, which is charging the battery. So it's now one MOSFET which is doing back and forth. Just a two separate thing. One is passing here going, one is passing here from the battery going into the main, and here is from the main also passing here into the battery. Yeah, nice. Okay, so everything is good here. All the MOSFETs are good, and the machine is working. So we don't have any short on the any inductors because machine is working. So I don't think you have a 40 inductors or short. And to my opinion, this problem shows that something is taking too much power. Something is taking too much power. That's why the machine shut it down by the EC chip. Yeah, because the battery is working already. I think something is taking, and either something is doing too much work. Yeah, some overload on a certain component. Certain component is doing overwork. Maybe because it runs good on the battery until you plug a charger. Because when you plug a charger, the ability of working is more than on the battery. Because something is operating through the battery and you apply the charger current from another one to it. So which means you are doubling the load. And so if that kind of component can't even handle it, the ACH chip will shut it down. I think this is it. So we need to check which kind of component is doing this. And for that matter, we need to use the thermal camera to monitor all the components. Yeah, their behavior and their behaviors. Right. We need to monitor all the components. So let's start. We need to plug the charger. Yeah. I have my thermal camera here. And then we are starting monitoring the. We have something here. Mm, okay, it's working. No, nothing here. Hmm. Everything is cool. EC chip. EC chip is cool. Look at this. So you can see, nice. But what about this thing? Something is here. It could be normal. It's behind the data. Maybe it's a 3.3. But if this component is working, then we need to get it's working normal. When you see a little heat, which means it is working, it is doing something, right? So in this case, we need to check whether it's working or not. We need to get something here. No, it's not doing anything, but it was heating. Nothing, you are not doing anything. You are doing nothing, but you are heating. How? Is it possible? I see some heat, but this guy is not doing anything. How is it possible? Check. Just a quick. No, very bad. No, proper hot. This is the highest. Remember, I bent my finger. Yeah, bend my finger when I just touch this particular IC. Too bad. He's doing overwork. And we need to check something out here. Hmm. Okay. Then off. Okay, I don't need the voltage, so let's move the charger and try the resistance. So yeah, good. Yes. Input voltage. Yeah, good. No, but this one good. This one good. This one good. This one good. Over the back, good. This one good. Yeah, it's a ground. Yeah, it's a ground. And here. So what's the problem? This IC is not good. But this thing looks very weird. I don't think this thing is good. This one is the pull-up resistor, right? And then let's check the voltage on this place. So what do you have here? 5 volts. No, what's going on? Ah, okay. 5 volts. We should get a 5 volt here or something for something. So, oh, okay, okay. Let me check here. This one is a 5 volt regulator. 5 volts is here, and 5 volts is here. Yes. See how clean this is? It. No, it looks weird. There's something is not right with this place. And now it says something. How about here? No, what we get here is the same as here. We're supposed to also get it here. No, I need to change this thing. Yeah. So I'm coming. Yeah. And resistor, I can get it anywhere. We need 100 ohms for that. Okay. Five. Yeah, yeah. This is how it's supposed to be. Maybe let me see. 5 and 5. Yeah, yeah, yeah. This is how it's supposed to be. So now we fix it. We fix it, and let me check. Let's see. Yeah, it's just minimum heat. It's not too high, so let's start it. Start it. Makes sense. It's minimum, as you can see. Yeah, this is it. Check. Not too high. Let me touch it. Yeah, can put my finger on it all the time. Nothing happens to my finger. It's good. It's good. It's good. It's good. We fix it, and then